Today we're going to be learning about multiplying integers using counter manipulatives. One huge advantage of using counters is that students will obtain a visual representation of exactly how multiplying positive and negative numbers are done. A disadvantage is that if the counters are used improperly, it can lead to confusion, especially when dealing with multiplying two negative numbers. It is important to remember the definition of an integer. The definition of an integer says a positive or negative number, or zero, that does not contain any fractional component. For our lesson today, yellow counters will serve as positive numbers and red counters will serve as negative numbers. The text that corresponds with our lesson for 7th grade math is 2C. 2 says, number, operation, and quantitative reasoning. The students add, subtracts, multiplies, or divides to solve problems and justify solutions. The student is expected to use models such as concrete objects, pictorial models, and number lines to add, subtract, multiply, and divide integers, and connect the actions to algorithms. Today, we will be using counters as concrete objects and multiplication as our operation. Here is a practice example that you may see on a future STAR exam. This problem states, a bank charges a penalty of $35 for each check returned for insufficient funds. Suppose that a customer miscalculates his balance and writes 3 bad checks. Which equation expresses the effect of the penalty on his checking account? By looking at the answer choices, we can see there are numbers that represent a positive times a positive, a negative number times a negative number, and a positive times a negative number, which are all topics that we will be covering in this lesson.
In our first example, we are doing the numbers 3 times 5. Whenever you multiply, the first number is the number of sets and the second number is the number in each set. So in this example, we have 3 sets of 5 each. Also, since the first number is positive, this can be thought of as repeated addition. Alright, and whenever multiplying a positive number by another positive number, the product will always equal a positive number. I'm going to demonstrate this through using the counters. So our first set is a group of 5. So that is one set, and now I'm going to put another set of 5. And then one last set of 5. Notice that all of the counters are yellow because we are using positive numbers. So this represents positive. Alright, and then to find the answer, you can count how many counters there are. So there's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. So 3 times 5 is equal to 15. Also, since this can be thought of as repeated addition, you could do 5 plus 5 plus 5, which will also give you an answer of 15.
In our next example, we'll be focusing on 2 times negative 7. Similar to our last example, our first number in this problem is a positive number. Therefore, we can also look at this as repeated addition. It is important to remember that in mathematics, a positive number multiplied by a negative number will equal a negative number. I will demonstrate this rule using the counters. Since our first number represents the number of sets, we know that we must have 2 sets with 7 counters in total in each set. So we'll first start by demonstrating as our first set. And this as our second set. We can then count each counter within each set. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, and 14. Therefore, we have a total number of 14. However, it is also important to note that we're using the negative side of our counters, which is why they're represented in red. Also, each of our sets are negative, considering the negative 7. Therefore, our 14 must be represented as a negative number.
Before introducing the next example, we need to go over a concept. If you have a -1 and a +1, these two will cancel each other out because -1 plus +1 is equal to 0. Therefore, if you need to add extra counters to your expression, you can add these two paired together and it will not change the value of what you had before. Alright, so in this example, we have -4 times 3. You will notice that our first number is no longer positive. Since the first number is negative, this can be thought of as repeated subtraction. A negative number multiplied by a positive number will always be a negative number. I'm going to demonstrate this using the counters. Now, we have -4 times 3. Again, since this is thought of as repeated subtraction, what we are doing is having 4 groups that subtract 3 each. So I will start off with no counters because there are no counters right now on the paper, and since we need to subtract, we need to add counters. So going back to what I was saying before, you can add a positive and a negative put together without changing the value of anything. This +1 plus -1 is still 0. So I'm going to do this again and one more time. Now I have enough to subtract 3 counters. And in order to subtract, I'm going to take away the positive ones. That was one set. I have to do this 4 times. So here would be another set. Then I can take away the positive. And then another set. And subtract 3 from this one, and then one more set, and subtracting 3. This leaves us with only negative counters, and through counting these we see that we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. And remember, since the counters are red, this will be a -12. Another way that you could do this is to think of these in groups of 3. Do -3, -3, -3, -3, -3, as we were saying before, which is repeated subtraction.
Similar to our previous example, this example starts out by using a negative number. As we learned before, a negative number can be represented by using repeated subtraction with the counters. It is important to keep in mind that when multiplying a negative number by another negative number, the answer will always result in a positive number. Previously, we learned that if we start out by using the opposite of our counters, we know that this will be neutral, or it can also represent as a 0 because we have 5 positive counters and 5 negative counters. Therefore, our result is 0, or the counters technically don't exist. Since we are subtracting, because we're using repeated subtraction, we're subtracting a negative 5. Therefore, in this problem, we will remove all red counters, which will leave us with 5 positive. We will repeat this process because we must have a negative of 2 sets. Again, these 10 counters represent as a neutral. Subtracting the negatives from it, we're left with 5 positive. Therefore, a negative 2 times a negative 5 using repeated subtraction results in a positive 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Negative 2 times negative 5 equals positive 10.
Now that we have gone through several examples of multiplying with integers, we can go back to our standardized problem. The problem says a bank charges a penalty of $35 for each check returned for insufficient funds. Suppose that a customer miscalculates his balance and writes 3 bad checks. Which equation expresses the effect of the penalty on his checking account? Now, we talked about how the first number in an expression represents the number of sets. And in this problem, it says that the customer wrote 3 bad checks, so there should be 3 sets. Also, since it is a penalty of $35, we can assume that the sets are of negative numbers. So, using our counters, here is an example of what the first set would look like with our 35 negative counters. And to solve this problem, you would repeat this step and add 2 more sets of negative counters. And then you could count them or add negative 35 3 times to find your answer of negative 105. Now looking at our answer choices, negative 105 is B and D, so we can eliminate A and C automatically. So just looking at B and D, we have 3 times negative 35 equals negative 105, and negative 3 times 35 equals negative 105. However, remember that there's a penalty of $35, so the 35 is negative while the 3 is positive, giving us our answer of B. 3 times negative 35 is equal to negative 105.
Throughout this lesson, we've demonstrated how to correctly multiply integers using counters as manipulatives. When used correctly, these counters serve as a great visual tool for learners. In our previous examples, we showed how to multiply a positive number times a positive number times a negative number times a positive number, and a negative number times a negative number. We hope that this lesson will now help you multiply integers using counters.